Hi students, today we are going to start a new chapter, volume and surface area of solids. Solids means which occupy space. We have cube, cuboid, like that, etc. Today I am going to teach you about cuboid. What is a cuboid means? A cuboid will have 6 faces, 12 edges and 8 vertices. For example, chalk piece box or brick. If you see this chalk piece box, it is in the form of a cuboid. 6 faces are there. You can see count. And 12 edges are there. 12 edges. And 8 vertices are there. This is shape of a cuboid. We have learned in the previous classes itself. If all sides are equal, it is a cube. But here in cuboid, length, breadth and height will be there. These 3 will be different. So here I have drawn the cuboid, longest length, breadth and height. Now first one, volume of a cuboid is equal to length into breadth into height. In shortcut, L into B into H, that is about LBH. Cubic units, 3 times we are multiplying, cubic will come. So second one, from the same formula I am writing these 3 formulas obtained. Suppose if you want to find length of a cuboid, volume by breadth into height. Breadth if you want to find, volume by length into height. Units only you will get here, units. And third one, suppose if you want to find height, volume by length into breadth, units. Next, third one, diagonal of a cuboid, diagonal, diagonal, opposite vertices. Diagonal of a cuboid is equal to square root of L square plus B square plus H square. Here also units will come. Next, fourth one, total surface area of a cuboid is equal to 2 into LB plus BH plus HL. LB means L into B. BH means B into H. HL means H into L. We have to multiply. Here 2 times we are multiplying, so square units will come. Next, fifth one, lateral surface area of a cuboid or area of 4 walls of a room. For this both same formula, 2 into L plus B into H. 2 into L plus B into H. This is already perimeter into height. So here we are adding unit again into unit, square units will come. So this is the formula of cuboid. If you know these formulas thoroughly, then we can do this volume of cuboids very easily. So read, learn and by heart carefully. Next solid is cube. Here the length will be same, breadth will be same and height also will be same. If all the 3 sides are equal, then we call it as cube. Length A units, breadth A units, height also A units. Then volume of a cube is equal to A into A into A, that is equal to A cube. 3 times we are multiplying, cubic units. Second formula, diagonal of a cube, diagonal A into root 3, A root 3 units, or you can write root 3 into A also, both mean same. Third one, total surface area of a cube is equal to 6A square. 6 areas will be, faces will be there, square units. Next, fourth one, lateral surface area of a cube, 4A square. 4 into area, 4A square. These are the formulas. You have to read, learn and by heart. Next, relation between various units of volume. Length units, 1 centimeter is equal to 10 millimeters. We have learned in our previous classes. Now we are changing to volume units. Volume is 3 times we are going to multiply. 1 centimeter cube. 10 into 1 centimeter, how much? 10 millimeters. 10 into 10 millimeter cube. So 10 tens are 100, 100 tens are 1000. So 1000 millimeter cube. Next, 1 decimeter is equal to 10 centimeters. In the same way, 1 decicube is equal to 10 centimeters, not 10 into 10 centimeter cube. So 10 tens are 100, 100 tens are 1000 centimeter cube. 1000 centimeter cube will be equal to 1 liter. Please learn and by heart. Already have learned in your elementary classes. Now once again. Next, 1 meter is equal to 100 centimeters. 1 meter cube is equal to 100 into 100 into 100 centimeter cube. 3 times we are multiplying. So 10 crores centimeter cube. Thousands, ones, tens, hundreds, thousands, 10,000, lakhs, 10 lakhs. So 10 lakhs centimeter cube. Ones, tens, hundreds, thousand, 10,000, lakhs, 10 lakhs. So 10 lakh centimeter cube. 10 lakh. Keep in mind. Exercise 19. First problem. Find the volume, the total surface area and the lateral surface area of a rectangular solid having, in that second bit I am doing, length they have given 5.6 decimeter, comma, breadth they have given 2.5 decimeter and height they have given 1 meter. These two are in decimeters and height is in meter. 1 meter is equal to 10 decimeters. We have learned. So we will write solution. Given. What are given? Length is given. Length is equal to 5.6 decimeter. Breadth also they have given 2.5 decimeter. And height how much they have given? 1 meter. 1 meter is equal to 10 decimeters. So 10 decimeters. Everything is in same units, decimeters. First one they are asking to find volume of the rectangular solid, means cuboid. Rectangular solid. In bracket if you want, write cuboid. Rectangular solid is equal to L into B into H. That is equal to 5.6 into 2.5 into 10 decimeter cube. Always volume will be in a decimeter cube. Multiply. You will get 140 decimeter cube. If you multiply into 10, 25. 25 into 5.6. If you multiply, then you get 140 decimeter cube. Next, total surface area of a rectangular solid. Rectangular solid is equal to 2 into LB plus BH plus HL square units. that is equal to 2 into 5.6 into 2.5, keep in a bracket, plus 2.5 into 10, one bracket, plus 10 into 5.6 decimeter cube, decimeter square, because 2 times we are multiplying, decimeter square, that is equal to 2 into, multiply 56 into 25, 14 plus 2.5 into 10 is 25, again 10 into 5.6 is 56 decimeter square, that is equal to, add 14 plus 25 plus 56, you will get 95 decimeter square, 60, 70, 70 plus 25, 95, multiply 10, 0, 1, 18, 19, so 190 decimeter square. What is the total surface area? 190 decimeter square. Write clearly. This is D. 190 decimeter square. Next one, they are asking to find lateral surface area of a rectangular solid is equal to 2 into L plus B into H square units. So that is equal to 2 into 5.6 plus 2.5 into 10 decimeter square. 2 times we are multiplying. So 2 into, add 8.1 into 10 decimeter square, 2 into 81, because 8.1 into 10 is 81 decimeter square. 1 2s are 2, 2 8s are 16, so 162 decimeter square. Therefore, the lateral surface area of a rectangular solid is equal to 162 decimeter square. Second problem. The volume of a rectangular wall is 33 meter cube. If its length is 16.5 meters and height 8 meters, find the width of the wall. Solution given. What they have given? Volume of a rectangular wall. How much they have given? 33 meter cube. Next they have given length. Length of a rectangular wall. Rectangular wall. How much? 16.5 meters. Next they have given height. Height of a rectangular wall. Rectangular wall is equal to 8 meters. Now they are asking to find width. Width or breadth, both mean same. Width or breadth of a rectangular wall. Rectangular wall is equal to volume by, just now we have learned, L into H, length into height. Length into height. That is the volume how much? 33 by 16.5 into 8 into 8. Now multiply 16.5 into 8, 40 decimal 4, 48, 52, 5, 13. How much we got means 33 by 132. Cancel 3 table. 3 goes 11 times. 3 goes 6 times. Again 3 goes here 1. 3 fours are 12. 3 11s. 3 ones are 3 ones are. 3 fours are 12. 3 fours are 12. 11 ones are 11 fours are 1/4 meter, because all are in meters. No meter here, meter cube is there, here meter square is there, meter cube, here meter square. 2 meters will cancel and 1 meter will be left. So 1/4 of a meter means 1 meter is equal to 100 centimeters. So 4 goes 25 times. So what is the answer means 25 centimeters, or if you want to write means 0.25 meters, or if you want to show in meters means 0.25 meters. Anything same only. Sir, these two are in meters now, sir. This also I want to keep meter means keep in meter, or otherwise into 100 if you do 0.25 into 100 is 25 centimeters only. So this calculation is very important. Multiplication and division and everything are part and parcel of the problem. 3 table cancels, or directly 33 table you can take. 33 ones are 33 fours are, or 11 table you take. 11 3 table you take. 11 by 44. Again 11 table 1 by 4. Fourth problem. A classroom is 12.5 meters long, 6.4 meters broad and 5 meters high. How many students can it accommodate if each student needs 1.6 meters square of floor area? How many cubic meters of air would each student get? 2 questions they have given, we have to solve. Solution given. Length of the classroom. Length of the classroom. How much they have given? 12.5 meters. Next, breadth. Breadth of the classroom. Breadth of the classroom is equal to 6.4 meters. Next, height of the classroom. Height of the classroom 5 meters. Now, here they have given each student needs how much? 1.6 meters square of floor area. So, first we will find area of the floor of the classroom. Area of the classroom. Length into breadth. L into B. That is equal to 12.5 into 6.4 meters square. Multiply carefully. How much you get? 80 meters square. 80 meters square. Now given in the problem, each student requires each student needs how much? 1.6 meters. Now they are asking how many students, that we are going to find now. They are asking to find number of students. Number of students can accommodate in classroom. How many? Number of students, that is equal to 80 by 1.6. Here also meter square we got, here also meter square get cancelled. Multiply with 10. 80 into 10 by 1.6 into 10. Why I am multiplying? You know, because to remove the decimal. So 800 by 16. 16 5s are 80 and 0. So how many students can accommodate? Means 50 students can accommodate. 50 students can accommodate in the classroom. Now they are asking to find how much cubic air is needed. So first we will find volume of air needed in the classroom. So volume is L into B into H. 12.45 into how much? 6.4 into 5 meter cube. Multiply. When you multiply, 400 meter cube will come. 400 meter cube. Now they are asking to find what? Next question. How many cubic meters of air would each student? Air required for each student is equal to volume of the room 400 by here meter cube by number of students 50 students. 0 0 get cancelled, 5 goes 8 times. So how much air for each student means 8 meter cube. How much? 8 meter cube. Therefore air required for each student in the classroom is equal to 8 meter cube. Fifth problem. Find the length of the longest rod that can be placed in a room measuring 12 meters into 9 meters into 8 meters. So solution given. What they have given means length of the room. How much they give? 12 meters. Next, breadth of the room. How much they give? 9 meters. Next, height of the room. How much they give? 8 meters. And they are asking to find length of the longest rod. Means length, breadth and height. If you take diagonal, that will be the longest rod. So length of the longest rod in a room, how much means length of the diagonal of the room. Diagonal means from one corner to the opposite corner. Length of the diagonal of the room. We know the formula for diagonal of the room. What is the formula for diagonal of the room? Square root of L square plus B square plus H square. Are you able to follow? So that is equal to, now square root of 12 square plus 9 square plus 8 square. 12 12s are 144. 9 9s are 81. 9 9s are 81. 8 8s are 64. Add. If you add square root of 289, add carefully. 4 4 8 9 10 14 4 8 and here 1. What is the square root of 289? 17. 17 meters square. Add 144, 81, 64, 9, 18, 1. Show the addition. How you are adding. Square root of 289 is 17. 17s are 89. So therefore, write the conclusion. Therefore, the longest rod required in the room is equal to 17 meters. Write the conclusion.